Lesson 3, Advanced Integration Techniques, How to Log Function Types, Part 2. Example 1. Verify by differentiation that the integral of 1 over the square root of x squared minus a squared dx is equal to the log of x plus the square root of x squared minus a squared, for x being greater than the absolute value of a. Now, if you recall, when you differentiate a log function, you need to differentiate what's inside the brackets and put it over this particular function. So let's just do that. We'll differentiate this part inside. So we'll have that d dx of x plus x squared minus a squared to the half is equal to 1 plus, the half comes down, 1 half x squared minus a squared to negative a half, look inside the brackets, times 2x, and that's equal to 1 plus x over the square root of x squared minus a squared. And we'll just tidy it up a little bit and put it over a common denominator, so it becomes the square root of x squared minus a squared plus x all over the square root of x squared minus a squared. Now we have to differentiate the function. So d dx of log of x plus the square root of x squared minus a squared, that will be equal to all this plus, oops, let's cross that, hang on, it's a bit messy there, plus x all over the square root of x squared minus a squared divided by the square root of x plus, oops, sorry, that should be, here we go, it's going to be x plus square root of x squared minus a squared. We invert and multiply, and it's going to be the square root of x squared minus a squared plus x over square root of x squared minus a squared times 1 over x plus the square root of x squared minus a squared, because this will cancel, all this will cancel with all this, and we get 1 over the square root of x squared minus a squared, which of course means that we've got that situation here, so it's the same. So that means that if we integrate that, so the integral, therefore the integral 1 over the square root of x squared minus a squared dx will equal the log of x plus the square root of x squared minus a squared plus some constant. Now you also, these are standard integrals, you can do the same thing with this one. Squared dx is equal to, let's drop that out, equals the log of x plus the square root of x squared plus a squared plus a constant. Now these are both standard integrals, and we will be doing some another example with these ones here, but that should be on a standard table, or in the HSC they have it on a particular sheet they hand out to students. Right, in example 2 we have to find the integral of 1 over the square root of x squared minus 6x plus 13 dx. And before I do that, I'll just write out those two rules again. Okay, we're going to have the integral of 1 over the square root of x squared minus a squared dx is equal to the log of x plus the square root of x squared minus a squared. Or we could have the integral of 1 over the square root of x squared plus a squared dx is equal to the log of x plus the square root of x squared plus a squared, obviously plus some constant. Now, you'll notice here that this x squared minus a squared is the whole thing under the square root sign in both cases. So virtually they're the same thing. So let's just complete the square on this one. Let's see if that's going to be equal to 1 over square root of x squared minus 6x plus 9. There's be a plus 4 here, dx. And of course that now becomes 1 over square root of x minus 3 all squared plus 4 dx. So this falls into this category here, right? So it's an x squared plus an a squared. But all we need to worry about is this first bit here, and that becomes the log of x is this x minus 3 plus the square root of, and you just put the whole thing in as you had before, x squared minus 6x plus 13 plus some constant.